Hello everyone, I'm Dr. Buddhi Kaliyanige. So today I would like to talk about covalent compounds problem solving. First question. So which element has the outer electron configuration of S2P4? There are four answers given: calcium, chromium, germanium and selenium. So let's write the electron configuration of of these elements and then find out which element has S2P4, the outer configuration. Calcium atomic number 20, then the configuration is argon 4s2, that is noble gas shortcut, and C24 for chromium, 4s1 3d5, germanium, C number atomic number 32, then argon 4s2 3d10 4p2, selenium atomic number 34, that is 4s2 3d10 4p4. These are the electron configurations of four atoms. Now, what is the outer shell? Outer shell means n number is higher, we call outermost shell. So you can see in this diagram n is equal 1, the energy level next to the nucleus, n is equal 2, n is equal 3 and n is equal 4 is the outermost shell. So according to these given electron configurations, larger n number is the outermost shell, that is n is equal 4. So if we consider this red color 4, which configuration is equal to S2P4, the last one, selenium, 4s2, 4p4. Question number 2 is how many unpaired electrons does a gaseous atom of phosphorus in the ground state? The phosphorus atomic number is 15. If we write the configurations, it is 1s2 to 3p3, or in the normal gas notation, it's neon 3s2 3p3. So let's draw orbital diagram for the 3s2 3p3 valence electrons. Valence electron means the outer shell electrons we call the valence electrons. So 3s2 3p3, there are 5 valence electrons for phosphorus. If you draw an orbital diagram 3s2 3p3, there are 3 unpaired electrons in phosphorus at the ground state. So how many unpaired electrons is the question? The answer is 3. Question number 3. What is the total number of valence electrons in chlorate ion? Chlorate, ClO3 minus. This is derived from chloric acid, HClO3. It is one of the strong acid. Let's talk about chlorate minus. The main group elements. Main group means in the periodic table 8 taller columns. We called main group elements. The first two are taller, group 1A and group 2A, alkali metals and alkaline earth elements. Last 6 columns, 3A to 8A, are taller columns. So 1A, 2A, 3A up to 8A are main group elements. For the main group elements, valence electrons is equal to their group numbers. For example, group 1 elements. Group number 1, then valence electrons 1. Group number 5 elements. Nitrogen, phosphorus, arsenic group. All the group 5 elements, valence electrons 5 and so on. Now let's go and calculate the valence electrons. Chlorine in group 7, so there are 7 valence electrons times 1 chlorine atoms in the chlorate ion. 7 times 1, 7 electrons. Oxygen. Oxygen in group 6, 6 valence electrons times there are 3 oxygen atoms in the chlorate ion. So 6 times 3, 18. And if the ion containing negative charge, we need to add 1 electron to the electron count. So we added 1 electron. Then total 7 plus 18 plus 1, 26 total valence electrons on the chlorate ion. So answer is B. Next question. Which set contains only covalent bonded molecules? The theory is the covalent and the ionic. Covalent is non-metal bonded to non-metal. They are covalent. Or in other case, metalloid bond to non-metal. They are also covalent. Ionic means metal bond to non-metal. We call ionic compounds. Covalent compounds, no metal include. Now let's go and find out. There are four answers given. First one, boron trichloride, SiCl4, PCl3. So boron is a metalloid, silicon is a metalloid, phosphorus is a non-metal, all the chlorines are non-metals. So answer is correct. Second one, ammonium bromide, N2H4, HBr. So everything looks correct, but ammonium bromide. Ammonium bromide is made by ammonium plus cation and Br minus anion. So ammonium plus cation and Br minus plus minus electrostatically attract to form ammonium bromide. So cation and the anion, positive charge ion and the negative charge ions electrostatic attraction form ionic compounds. Therefore ammonium bromide here we consider as ionic. So B is not the answer. C. H2, H2S are covalent. However, sodium iodide, there is a metal here. Sodium is group 1 metal. Then there should be ionic. D. Aluminum, ozone and arsenic. There are metals included, aluminum, and that is ionic. The answer is not D. So the correct answer is A, BCl3, SiCl4 and PCl3, they all are covalent compounds. Let's talk about the fifth question. Which species is isoelectronic with NO2 plus? Isoelectronic meaning is same number of electrons with NO2 plus. There are four answers given: N2O, NO2 minus, NH2 minus, and SO2. So first let's count total valence electrons on NO2 plus ion. Nitrogen 5 valence electrons times 1 nitrogen atom 5 electrons. Oxygen 6 valency times 2 12 electrons. Charge. So NO2 is a plus charge. So if the ion containing plus charge, we need to subtract electron. So 5 plus 12 is 17 minus 1 is 16 total valence electrons on NO2 plus. Now N2O 16 electrons total, NO2 minus, 17 valence electrons, NH2 minus, 8 valence electrons, and SO2, 18 electrons. You can follow the same method like this electron count on NO2 plus to find out these four answers. Now, which answer is correct? 16 electrons on N2O, that is equal to the 16 on NO2 plus. So they are isoelectronic. The answer is A. Let's move on to last question. What is the arrangement in space, the hybrid orbitals of the atom with sp2 hybridization? There are four answers given. They are molecular geometries: linear, bent, pyramidal, and trigonal planar. What are their hybridization? Linear geometry is sp hybridization. For example, BeCl2. BeCl2, beryllium is the central atom. So there are two chlorines attached to beryllium. It is sp hybridization. S orbital and p orbital hybridized to form two sp hybridized orbitals. So each sp hybridized orbital on beryllium overlap with two chlorine atoms, three p orbitals. Bent shape. Bent shape are sp3 hybridization. For example, H2O, H2S. So here two bonds and two lone pairs. There are four orbitals mixed together, 1s and 3p, to form four sp3 hybridized orbitals. Pyramidal shape or trigonal pyramidal shape, for example, ammonia, they are sp3 hybridized, 3 bonds and 1 lone pair. So here again, one s orbital mixed with 3 p orbitals to form 4 sp3 hybridized orbitals. 3 hybridized sp3s overlap with hydrogen 1s orbital on ammonia and the remaining sp3 hybridized orbital containing a lone pair electrons on nitrogen. Last one, trigonal planar. Example BF3, BCl3, formaldehyde, they are trigonal planar. There are 3 bonds, 0 lone pairs. So sp2 hybridization. 3 orbitals mixed together, 1s, 2p. 3 orbitals mixed to form 3 hybridized orbitals. So number of orbitals mixed is equal to the number of hybridized orbitals formed. So each sp2 hybridized orbital on boron overlap with fluorine's 2p orbitals to form BF bonds, 3 equal length BF bonds. So I hope now you will understand hybridizations and molecular geometry. If you want to find out more details, please go and check in another video in my YouTube channel about hybridization. Thank you all for watching. If you find this helpful, please subscribe to the channel and comment any specific area if you would like to discuss in the future.